in this problem, we are being asked to find the magnitude and direction of the force of the thruster. And so I just said that the force of thruster is like that because I am gifted with the foresight of knowing what the answer of this problem is. But you could honestly put that force wherever you wanted, and the math would work out the same. Now, we're going to set our coordinates. X is in that direction, and we're going to say that y is up. So, first thing, we are going to make our equations, our impulse momentum equations for the x and y directions. So, f of x times t is equal to mv final x direction. Oh, and we're saying that in this path, basically, final initial. Yeah. Minus mv initial x and fyt equals mvfy minus mvfv iy. Yes. All right, so first and foremost, we can tell that there is no there's no vector of velocity going in the y direction in the final spot because it's all going in the x direction. So we can actually say that this is 0. Then we don't have these numbers, the vix and viy. We only have an initial vi. So what we're going to do is use a little bit of trigonometry magic. And that's supposed to be a right angle, but we're just going to go with it. If that's 30 degrees, and we know that this is v initial, this is v in the y direction and v in the x direction. Using SOHCAHTOA, we know that this is going to be sine, because the y direction is in the opposite of the 30-degree angle, and the x vector is adjacent to the 30-degree angle, so this is going to be cosine. So now we can substitute in our known values into this problem like this. So for our x direction, force x times t is equal to, and then the final velocity is the same as the initial velocity as stated in the problem. So that's also 600 meters per second. So v, and you can even just say v initial, minus v initial times the cosine of 30, cosine from here, and fyt is equal to negative v initial sine, of 30. There we go. And now let's substitute all in our known numbers. So we have fxt equals, fx times 10 seconds equals 12,000 times 600 minus 12,000 times 600 times, no, not bad, times cosine 30, and we can find the fx is equal to 9646.2 newtons. 96,462 newtons. Then we solve for our Fy. Fy times 10 equals negative 12,000. Getting more space, I think. Down over there. 12,000 times 600 sine 30. And we get Fy is equal to 360,000 newtons. That's a lot of zeros. A lot of zeros. Negative, actually. Negative. Sorry. Now, this is not what the problem is asking for. They're asking for a total magnitude. So we are going to use a little bit of trigonometry magic. And we're going to say f of x, which is headed in the positive x direction, 9, 6, 4, 6, 2. And fy, which is in the negative y direction, so going down, negative 3, 6, 0 newtons. And this hypotenuse, and let me just make this a little bit larger. Never mind. Not going to work with me, no worries. But the hypotenuse, you can imagine, is going to be your final ft, okay? So, using this lovely theorem that we know, f of t is equal to 9, 6, 4, 6, 2 squared plus negative 3, 6, 0, 3 squared. And we get that your final magnitude is 372.76 kilonewtons. That's a lot of force. Now we also have to find the angle that this is headed in. And so if you just put a little theta to the horizontal, we can use more trigonometry. This is the tangent function. So tangent of negative 3, 6, 0, 0, 0, 0 over 9, 6, 4, 6, 2. And you can think of, and that's just like we were talking about before, TOA. So tangent, opposite, adjacent. So tangent is opposite over adjacent, which is what we just did here, is equal to theta, and then we can find that, never mind. I did it wrong. I did it backwards.
Inverse.
Yes, this is inverse tangent theta. There we go. Boom. Easy. Tan of your angle. Yes. Then we find that this is equal to 75 degrees. Boom. And so these two are going to be your final answer.